In this question, we are given that the value of the house in year 1985 is $102,000 and it had appreciated to $140,000 in the year 2005. So, in this case, we have to determine the annual growth rate, that is from years 1985 through year 2005. That's part one question. And part two, we have to determine the value of the house in 2010. So, let's see how to answer these two questions. So let's do part one question. Here we have to determine the annual growth rate from years 1985 to 2005. So for this, I'm going to use this exponential function, that is y equals ae raised to the power of rt, where y represents the value of the house after t years, a represents the value of house at the beginning of the year, or we say that when t equal to 0, and then r corresponds to the annual growth rate, and this will be in decimals when we use this in the formula, and t is the time in years. So basically, we have to determine the value of R, which corresponds to the annual growth rate. So for that, I'm going to use these two information. That is, in year 1985, I'm going to consider the year 1985 as the beginning of the year. So I can consider this as t equal to 0. The value of the house is 102,000. So therefore, we see that this is $102,000, and consider year 2005, that is, if we consider t equal to 0 for year 1985, then for the year 2005, this is a difference of 20 years from 1985 to 2005. So we consider t equal to 0, and then y equals $148,000. So we can plug these two values into the equation to solve for R. Let's do that. So plug in t equal to 0 and y equals $102,000. So we get replace y by 102. So 102 equals, this is a e raised to the power of r, which we have to find, and t equal to 0. So this is the equation that we get. We can solve for a from this equation. Notice that this quantity is e raised to the power of r times of 0 is 0, and e raised to the power of 0 is 1. So basically the value of this quantity is 1. So a times 1 is a. So we get a equals 102,000. So first we have determined the value of a. Now we can substitute this value of a into our exponential equation. So let me put that. So we get y equals 102,000 e raised to the power of rt. Now let's use the second information, that is, maybe I could just clear this. We are going to use this second information, that is, when t equal to 0, y is 148,000. This is $140,000. So I'm going to replace y by 148,000, and this is corresponding to t equal to 0. And this equals, that is, into this equation. When I do that, I get 102,000 e raised to the power of r we have to find, and t we replace by 20. Now we can solve for r from this equation. So first divide both sides by $102,000. So we can divide it $102,000. I'm sorry, it is 102,000. We can put only the numerical value. So these 102,000 gets cancelled, and we will have maybe we can just cancel these three zeros, and it reduces to 148 over 102, and this equals e raised to the power of r times 20 is 20r. Now we apply natural logarithm to both sides so that we can determine the value of r. So when we do that, I get natural logarithm of 148 over 102, and this equals natural logarithm of e raised to the power of 20r. Now, using the properties of natural logarithm, this comes in front. So basically, the right side expression equals 20r times of natural logarithm of e. Natural logarithm of e, its value is 1. So just to replace this quantity by 1. So therefore, 20r times 1 equals 20r. In fact, I can just remove this. So on the right side, we have only 20r. And on the left side, we have a natural logarithm of 148 over 102. Therefore, we can now solve for r. And after doing that, I also rearrange the r. So we get r equals, we have to divide both sides by 20. So we get natural logarithm of 148 over 102. So we have to determine this value of r by plugging the right side expression into the calculator. And when we do that, we get the value of r, and this is approximately 0.018611. And since we have to convert this into percentage, we multiply this by 100. So multiply this by 100. So r is approximately, when you multiply this by 100, we get 1.86%. I'm just considering only two decimal places, that is rounding to two decimal places. So R basically represent the annual growth rate. So we have determined the annual growth rate from years 1985 to 2005, and this is approximately 1.86%. Okay, now that we have determined the value of r, we can plug it into our exponential equation. So that is into the equation with a as 102,000. So therefore, we will get the equation as y equals 102,000 e raised to the power of r. I'm going to replace r in terms of its decimal equivalent. So therefore, this becomes e raised to the power of 0.0186 times t. Now, to answer the part 2 question, that is, we have to determine the value of house in 2010. So first, we have to determine the year 2010 corresponds to what value of t. Uh, we already uh, we already said that year 1985 corresponds to t equal to 0. So basically, we have to do the subtraction as 2010 minus 1985, and this gives 25. So therefore, we say that year 2010 corresponds to t equal to 25. So all that we do is we plug in t equal to 25 into our exponential function to determine the value of the house in year 2010. Let's do that. So therefore, we get y equals 102,000 e raised to the power of 0.0186 times t is 25, and we can plug this expression into the calculator. We multiply these two quantities and raise e to the power of this quantity and then multiply with the 102,000. And when we do that, we get approximate value of 162,385.45. This is approximated to two decimal places. So this is an approximate value. So we put approximation symbol, and this is in dollars. That is the value of the house. We see that value of house in year 2010, and this equals approximately $162,385.45.